Lesson 5.6, multiplying and dividing polynomials by a monomial this time. Okay, so this one should be fairly quick. It's really similar actually to 5.5. So you know what, let's just do an example of what we did in 5.5. So let's say this, if we had 3 times, and then we did things like this, right? X squared plus 4x, and maybe I'll even say minus 2, right? So this is a constant term multiplied by a trinomial in this case because there's 3 terms, right? Okay, so now what we're doing in this one is we're going to be multiplying a polynomial, so something like this, by, and then instead of a constant term like it was last time, we're just going to be multiplying it by something like 3x. Okay, so there's just going to be like an x involved there now too, okay? All right. So now let's do an example of what we did before. So if this was a 3, right, then we would have went 3 times x squared, and then 3 times 4x, and then 3 times negative 2, right? And we should have 3 terms in the end here. So this would all be 3x squared plus, and then 3 times 4 is 12x, and then 3 times, and you can consider this like negative 2. So 3 times negative 2 is negative 6 or minus 6. And there you go. So that being said, now, so think about that example. Now what we're going to do is go down a little bit. We'll do this. We'll just look at this example. So again, you know, so if we had 2x, so this is the difference, right, between this lesson and the last one. There's like an x involved on the number out front now. So 2x times 3x plus 4. Again, we're going to use the distributive property, which just means we're going to like rainbow it in, right? So it's going to be 2x times 3x, 2x times 4. But you see the new thing here, we haven't really done a lot of this, right? Where we have x times x, right? So here, let's do this. So this would be 2x times 3x. So I'm going to go 2 times 3 is 6. And then what is x times x? So we did this back in an earlier unit, right? X times x, if you think about it this way, that's like x times x. And remember, if we had x times x, that's really like x to the 1 times x to the 1. And what do we do when we multiply variables like this? We add the exponents. Remember that? So this would be, so if we're multiplying like this, it's x times x. We go 1 plus 1 is 2. So this would be the same thing as x squared. Okay, so that's what this would be in the end too. This would be x squared. Okay, and now the next part would be 2x times 4. Well, all we can do is multiply the numbers, right? So 2 times 4 is 8, and positive 8, so plus 8. And then it just has to be an x there still, right? Don't forget about the x. That's quite common that people would just forget to write it down. Just be careful on that. And yeah, so that's pretty much it. That would be our answer there. Okay. Like I said here, remember that x times x is x squared, not 2x, which some people would make that mistake, right? What they're doing, what the mistake there would be, is people are treating that like it's x plus x, right? X plus x, those are like terms, that would be 2x. But if I have x times x, that's x squared. All right. Okay, now dividing by like a binomial by a monomial. So binomial, remember, just means 2. So there's just 2 in that polynomial. Same thing, right? It's actually going to be really similar. Just instead of multiplying, we're going to divide. So in this last one, right, what we did is we multiplied everything by that front term. Well, now what we're going to do is we're going to divide everything by that. Well, instead, it's not front term this time. Now it's the term on the bottom, right? So we're going to divide this by 3x, and we're going to divide this by 3x. There's both of them. Okay? So what I've done here is I just wrote it out that when I have something like 9x squared minus 3x all over 3x, that really is the same thing as this, right? This example, 9x squared over 3x minus 3x over 3x. Just both those things over 3x. Okay? And then we just divide. So if I look at this one on its own, we've got, well, best way to handle this is just look at the numbers by themselves to begin with. So 9 divided by 3 is 3, right? So that's where that came from. And then x squared divided by x is x. And let's think about that for a second. That would be like, so x squared over x, and this is like x to the 1, right? And if you remember with your exponent rules, when we divide, what do we do with the exponents? We subtract them, right? 2 minus 1 is, well, that'd be x to the 1, wouldn't it? So that's why we end up with just a single x, right? X to the 1 down there. Okay, so that's what that becomes. And then here, well, we could do our exponent rules again. We can go 3 divided by 3 is 1, and x divided by x is 1. Or you can look at it and say, okay, this is the same thing divided by itself. Well, yeah, that's definitely going to be 1, right? But just for good measure, let's look at our exponent rules again, make sure this makes sense. If I had x divided by x, and we were thinking about this in terms of exponent rules, that's like x to the 1 divided by x to the 1, right? So that's going to be 1 minus 1 is 0. So that would be x to the 0. Okay, well, remember, anything to the power of 0 is 1, right? So that's why that's still equal to 1, okay? Or you can just think about them as canceling each other out too, right? I've got an x on the top, I got an x on the bottom. They cancel and become 1. You can think about it either way. I just wanted to show you that the exponent law still holds true, right? That still makes sense. Okay, so... But you know what? The good thing is in Math 9, these are pretty much going to be our examples, right? You're pretty much always going to have, like, you know, x squared over x simplifying down to x, or just x over x simplifying to 1. That's the most common. Every once in a while, you might get like an x to the 3 over maybe x to the 2. What would that be? Well, 3 minus 2. This would be the same thing as x to the 1, right? Okay. All right, now we're going to be using Algebra Tiles to kind of model some of the things we just did before, right? So, all right, this should be familiar too. It'll just be a little bit more going on now. Do you remember in the last lesson how this was our constant term along the side there? And they were always just like a small box, right? They were just like the small squares going down the side. This is what's different, right? Now, if we had something like this, right? Negative 4x, right? That's what this is. Negative 4x. Well, that makes sense, right? We have negative 4x's. Sorry, we have 4 negative x's, the other way of thinking about that, right? So we've got these white rectangles, and we've got 4 of them. So that's that one. And then across the top, we've got negative 4x plus 3. Okay, so this is my negative 4x, right? This part of it. And then the plus 3, well, that means I have, oh, that was terrible. Come on, I can do it. Yeah, there we go. We have positive 3 of those. Okay, negative 4x plus 3. Now, the thing that's going to change here, well, might as well leave that. Okay, the thing that's going to change here now is what happens when we multiply them. Do you see how these ones, we've got like a rectangle, and they end up making a square, right? So remember what the squares are. We haven't really dealt with them much yet. A big square is going to be x squared, right? And you can see that it fits in there while you're when you're making these, right? Be careful with the negatives and positives, right? Do you see how this was a negative and that was a negative? Well, negative times a negative, yeah, that's why this one's the black shade, right? And then on these ones, this one's negative, this one's positive. Negative times a positive gives you a negative. That's why these ones are all white. Okay, so that's the idea. And then, yeah, so you can just, looking at it, right? That's the good thing about Algebra Tiles. You can count them up once you see how they fit. There are 16, right? If I counted all of these, right? There's 16 of those, you know, which makes sense, 4 times 4. And then you have 12 of these negative x's that would fit into that spot, right? And that's where that comes from. Okay, so like I was saying before, just be careful with the colors, right? Positive and positive makes a positive. Positive times a negative makes a negative. So I'm talking about this, right, that I was just doing before. Like negative and a positive make a negative, right? So just that type of a thing going on. And yeah, 2 negatives make a positive. Okay, Now, you can also think about the same thing. This is actually the same picture. I just want to show you that you can think about this as a division statement. So, again, if I had something like 2 times 3 is equal to 6, right? That's my multiplication statement. Well, if I wanted to, I could write that a little different. I could write that as 6 divided by 2 is equal to 3, right? There's my division statement. Yeah, just this divided by this gives me this, right? Or it would be also true to say 6 divided by 3 is equal to 2. There's actually like 2 different division statements that you could see out of this, right? Okay, so looking at our example above, we could just start. We could just think about, the bottom. Think about this first, right? 16x squared minus 12, which is what this is, divided by negative 4x, right? Divided by this would give me this, right? That's the negative 4x plus 3. Negative 4x plus 3. Okay? So that's true to say that. Okay? And then, yeah, like I just wrote under here, would also be true just to kind of do the flip. You could also just say the product, right? The bottom, this, divided by this, right, the top up there, is equal to negative 4x. Okay, so just kind of flipping it, just like the example with the 2 times 3 is equal to 6 thing.